screen. Hey, so can you guys see my screen now?
Yes, sir.
Yes, sir.
Okay, good. So you guys already know about binary, about octal, about hexadecimal, and then about decimal. Now we have n base right here. We're in going back to the notepad. So again, the other bases, which is not binary, not octal, not decimal, and then not hexadecimal, we call them n base. Okay, so they just another base, but they don't have this kind of special names. Okay, so are we clear with that one? Hello, are we clear so far? And what are the n bases? Okay, good. Okay, let me just maximize this one so I can see your thumbs ups. Okay, very good, very good. Okay then. All right. So in here, let's do some conversion. So conversion from any base decimal. So we can actually convert everything, okay, any bases into decimal. So here are the steps. Okay, so to convert an integer number in any base decimal, add all the products of each digit multiplied to its base in increasing power starting from 0. Okay, and then to convert a fractional number in any base to decimal, add all the products of each digit multiplied to its base in decreasing power starting from -1. So here are the uh, call this one tips that I can give to you guys. So I'm say integer. So we're talking about whole numbers. So if you're going to get the uh, what is the correct term? If you're going to get the uh, forget the term, but if you're going to familiarize this process, okay. So when we say integer, we have an increasing power starting from 0. So if it's whole number, increasing. If it's a fractional number, okay, it's a decreasing power starting from -1. Now, I know that this one is quite confusing, especially if you're just going to analyze this one and then understand this one on how to, apply this one in real example. So let's now proceed to its conversion format. Okay, so in here we have, let's say any number as long as it's a whole number, and then any number wherein it's representing a decimal, okay, or a fraction part. Okay, so after this decimal point right here, this is already your fraction part. Okay, so in here, just line this one up from top to bottom. So A, B, C, X, Y, Z. Okay, so you don't need to put space in here. So this one is, just to emphasize that this is the part wherein we have decimal in here. So above is just the whole number, and then below is just the fraction number. So again, going back to this, uh, call this one rules or instruction on how to convert any base decimal. So when say integer number or whole number, so we have an increasing power starting from 0. Oops. So right here, starting from 0, we have an increasing number. So 0, 1, and then 2. So that's basically the exponent. Okay. And then right here for the fraction part, so we will start with -1 and then decreasing power, of course. So -1 and then -2 and then -3. All right. And then the base right here is whatever is the base of that specific number will be the one that you're going to put in here. So if this one is binary, then just put here 2, 2, 2, 2, and then 2, and then 2. If this one is octal, then just put here 8, 8, 8, and so on and so forth. If this is hexadecimal, then just put here 16, 16, 16, 16. Okay, so basically this is our multiplier. Okay, so the base right here. Okay, so let's have an actual example. Let's apply this one. So we have 6 examples right here. We have 110101 base 2. So in here, it is asking us to convert this binary into this decimal right here. Okay. So again, the first step that we need to do is line this one up from top to bottom. Okay. So here's the solution from top to bottom. So 110101, which is now this one, and then just multiply everything to its base, which is 2. So times 2 times 2 times 2 times 2. Kagi-Bunshin technique. Just kidding. Okay, anyway. So, yeah. Everything is multiplied by 2. And then from our lowest bit, okay, so starting from here, since we don't have fraction part in here, so this one is already 0. Okay, so 0 and then increasing power. So 0, 1, 2, 3, 4, 5 till you reach the highest significant bit. All right, and then just do the math. You can use your calculator for faster uh, computation, and then you will get 53 base 10. So if you want to solve it manually, then here's the computed value of each of those. So 1 times 2 raised to 5 is 32. This one is 16. This one is 0. This one is 4. This one is 0. And then this one is 1. Okay, so any number that is raised to 0 is 1. So 1 times 1 is 1. And then just add everything, and then you will get 53 base 10. All right, and then one more thing. So if we are in a face-to-face method, so you should always put the unit, okay, or the base. So this is an indicator that you have already converted this binary into decimal. So if you didn't put this unit right here, then you will get an incorrect answer. Okay. So that is only if we are in a face-to-face method. However, since we are in ODL or online distance learning, so you don't need, so in your quizzes or in your quiz, okay, since you only have one quiz for this module, so in your quiz for module 4, you don't need to put the base anymore. Okay, just put the number. So what is the uh, equivalence value of this one into decimal? Then just put 53. Okay, no need for 10. So are we clear with that one so far? And were you guys able to verify whether this one is correct or no? Okay, very good, Miss Kyla, Mr. Raymark. All right. How about the others? Okay, very good, Mr. Dan. All right. So I hope you guys were able to get on how did we, you know, convert this binary into decimal. Okay. So yeah. So let's have for example, just in case you're confused on how did we get this one. Okay. So in here, I have a different arrangement. So supposedly we will just line this one up from top to bottom, starting from here and then going down below. And then in here, so it's from left to right, and then left to right again, and then left to right, and then going down. So 1 1 is this one, and then 0 1 is this one, 0 1 right here, and then 1 0 is this one, 1 0, and then 1 right here is this 1. And then for the 1 0 1, we have 1 0 1 right here. Okay. So that's our arrangement. And then starting from the decimal point, so this one is 0 and above. So this is the 1 right here. So starting from 0 or raised to 0, next one is of course 1, 2, 3, 4, 5, and then 6. Okay. And then for the fraction part, so starting from here, we have -1, -2, and then -3, which is now this one, -1, -2, and then -3. All right. And then, of course, your multiplier. will be its base. So the base right here is 2, so just multiply everything by 2. So once you're done with this kind of arrangement, and after substituting their exponents and bases, then just do the math. Okay, using your calculator, you will get 109.625. Alright, so I would like you guys to verify whether this one is correct or no. Okay, letter B. Shh, I miss. So, do you guys have the same answer? Did you get 109.625? So as early as of now, I would like you guys to, you know, uh, do your own computation for you to be able to experience on how did we get these final answers. How was it? So is there anyone who's verifying whether this one is correct or no? 109.625.
Sir, correct.
All right. So I hope you guys have already got the idea on how to convert binary into a decimal. All right, so moving on. Okay, so don't you guys worry, we have four more examples. So in here, we have 4,536, which is an octal. Okay, so all you need to do is line this one up from top to bottom, starting from here, the highest significant bit. So 4,536, and then multiply everything to its base, which is 8. And then since this one is only whole number, then this one is already 0 and above. Okay, increasing by 1. So 0, 1, 2, and then 3. So just do the math, and then you will get 2,398. Okay, so please check if letter C is correct or no. Alright, so correct daw. Coming from Miss Kyla Quito.
Sir, correct po.
Alright, very good. Okay, so is there anyone who's confused on how did we get those results? So please let me know so I can guide you, and we can have more explanation regarding with that one. Alright, so I guess none. So next one right here is the same octal. However, this one now has a fraction part. So, but anyway, the same process. So just line this one up from top to bottom. So 1274. Okay, so starting from here, this one is the integer part or the whole number. So 0 and above. But in here, its exponent is -1 since this one is a fraction number. Okay, and then again just do the math using your calculator, and then you will get 87.5. So please let me know. Oops, okay, so there is a question. So sir, clarify ko lang po, yung base 10 is just a unit po. Yeah, so the 10 right here is just a unit, or an indicator actually, or a label. Okay, meaning you were already converted this one into a decimal. So take note, we have a lot of bases. It just happened here that we are converting any base into decimal. So that is why our final answer in here is always decimal. Okay, so we can also convert binary to octal, wherein, of course, if the answer is octal, then we have to put a base of 8. There are also cases wherein you have to convert hexadecimal into binary. Well, of course, you have to put a unit of 2, okay, as its base, since that is the question. Okay, so I hope I was able to answer your question, Miss Kyla. Any other questions so far
Yes,
before we
sir.
proceed? Okay, good. So let's now proceed to the letter E. So in here we have hexadecimal, which is B65F. Okay, wherein again going back to the table in hexadecimal, so 15 or F is actually 15 in decimal, and so on and so forth. So A is 10. So in here, wait lang guys, stay there. All right. So in here we have letter B, wherein in decimal that's actually 11. So just convert this one uh, as soon as possible once you are solving this one in here. Because if you're going to put here B, so B times 16 is of course not possible. So you have to get the decimal value of this one, okay, which is 11. So 11, 6, 5, and then F is 15. And then multiply everything by 16, and then from here is 0 and increasing by 1, so 0 1 2 3, and then just do the math, and then you will get 46,687, okay, base 10. Okay, and the next one right here is the same uh, concept, just that this one has a fraction part. So A is 10, and then C is 12, and then E is 14, and then lastly is 8. So multiply everything by 16, and then starting from here we have 0 and then 1, and then starting from here we have negative 1 and then negative 2. Okay, which is now this one. So negative 1 and then negative 2, 0 and then 1. And then just do the math with your calculator. Okay, and then you will get 172.9625. So please check if you guys have the same answer. Depending on the question, Miss Kyla. So her question is, do we need to put all the decimal places? So if let's say in the question, I wasn't able to indicate that you need to put two decimals only. So just put everything. If there is no instruction that you can only put two decimals. Okay. But I'm pretty sure that I was able to put how many decimals you're going to put. Okay, so depending on the question. Okay, so do we have the same answer? Were you guys able to verify whether letter E and F is correct or no? Okay, so correct daw, sabi ni Miss Kyla. Okay, it's also good with Miss Johnny Riza. Alright, so okay, so remark, Mr. Perez. Alright, so next right here is the n base, which is the same idea, just a different base. So we have 12.2 yeah, 12.2, and then it has a base of 3. So same concept. So I just list this one from top to bottom. So 1 2 2. So in here we have a multiplier of 3, since that is the base of this example. So multiply everything by 3. And then starting from here, we have 0 and then 1. And then right here is negative 1, which is now those exponents. And then again, just use your calculator, and then you will get this result, 5.6666 base 10. All right. So the same with this one letter B. It's just a different base, but same concept. So 1, 2, 3, and then 1. So starting from 3, we have raised to 0, and then raised to 1, and then 2. And then in here, we have raised to negative 1. And then again, just do the math with your calculator. You will get 38.2 base 10. Okay. So were you guys able to verify whether this one is correct or no? Okay, so I think Miss Kyla already got this one. Mr. Remark is already good with this one. Correct answer. All right. Okay, very good. So I will not discuss this one anymore since we just have, same concept, just a different exponent. Uh, uh, Different multiplier rather. Okay. So in here, just multiply everything by 9. In here, just multiply this one by 13. And then in here, of course, you have to convert this one into decimal, which is 10. And then B is also into decimal, which is 11. And then just do the math, and then you will get those results. Okay. And then in here, we have supposedly this one is your exercise number 1 if we are in a face-to-face method. But since we are not in a face-to-face discussion, so I will not give this one to you guys anymore. So again, you only need to answer one activity per module, which is a quiz. Okay, so you're only going to have one quiz for this entire module 4. Okay, so with this one, so this could serve as your practice assignment, you know, to enhance more your knowledge on how to convert the following number system, so any base into decimal. Okay, so you can also message me to my Canvas account or to my Facebook account if you want, just to send your solution, to let me check your solution if you are really doing the correct way of converting that one. Okay, so moving on, we have okay, so let me just write this one down. So if we have any base to decimal, we can also have decimal to any base. Any base. Okay. So all you need to do is reverse engineer it, or you can apply this algorithm right here, or steps right here. So we have 3 steps on how to convert decimal integer to another base. So take note, this is only decimal integer, meaning a whole number decimal. So we have a different process or steps when it comes to fraction decimal or decimal fraction, okay, into another base. But let's talk about whole numbers for now. So step number 1 is repeatedly divide the given decimal number by the base where you want the decimal to be converted to until the quotient is 0. Second step, for each division operation, tally the remainder. And then lastly, if the quotient is already 0, write all the tallied remainders by reading them in upward direction, so meaning from bottom to top. Okay, so again, for you to appreciate these steps right here, let's apply this one in real example. Okay, so we have this example right here. So decimal to binary conversion. So we have this decimal 13 base 10, and then it is asking us to convert it into binary. Okay, so just to give you an idea on what is the result of that one. So if it's asking you to convert it from decimal to binary, then expect that the answer will only compose of 1 and 0. Okay, if you have 2, 3, 4, 5, 6, 7 on that example or on that question, then your answer is already incorrect. Okay, because in binary you only have two numbers, which is 1 and 0. So the same with, let's say, decimal to octal. Okay, so your results should only compose from 0 to 7. Okay, so if your answer has a value of 8 and then 9, then that one is already incorrect. Okay, that is because that is not octal anymore. Okay, once you've reached this one is already n base. Okay, this one is ninth base, and then this one is 10th base. Okay, so I hope you guys get the idea on what could be the result of this one if you're going to convert this decimal into binary. All right, so anyway, so here's the solution on how to convert this decimal right here into binary. So just get the decimal number and then divide it by, let's say, into what uh, format or what number system you want it to be converted to. So in here, it's asking us to convert this one to binary. So our divisor will become 2. So before, we're always using, multiplier. But in here, of course, you have to reverse engineer it, wherein, of course, from multiply, it will become division. So just do the opposite, okay? And then in here, of course, so 13 divided by 2, just separate your answers into two parts. So the first one is integer quotient, and then the next one is remainder, okay? So 13 divided by 2 is, to be exact, it's 6.5. But since, we're going to separate those two by integer quotient or whole number only, and then a remainder, then this is the result. So 6 right here, and then 1 for the remainder, okay? And then for the next one, just get whatever is the last value in integer quotient. So 6 divided by 2 is 3. So of course, remainder 0. And then just copy this 1. So 3 divided by 2 is 1, remainder 1. And then 1 divided by 2 is cannot be. Okay, so just put here 0. Okay, because we cannot divide this number anymore. So in here, whatever is the number or the final number in integer quotient, so just put it right here as your remainder. So it says here that if the quotient is already 0, then write all the tallied remainders by reading them in upward direction. So in here, once you reach a value of 0 in your integer quotient, then that's the time that you will stop dividing the integer quotient. Okay, and you can now read the remainder from bottom to top, and that will serve as your final answer. Okay, so 1 1 0 and then 1, which is now this one. So 1101 base 2. So from decimal into binary. So as you guys can see, we only have two numbers, which is 1 and 0. Okay, that's it for binary. All right, so are we clear so far on how did we get this result? Okay, very good. Mr. Dan, Mr. Perez, Mr. Van Luther, Miss Selayan, Mr. Bremark. Alright, let me just move this one. Okay, Mr. Jomsalan, Mr. Miss Kyla. Alright, very good. Okay, so let's have more example. Okay, letter B. So find 37 base 10 into base 2. So let me just check how many minutes do we have more. Where is the time stamp? Okay, so we still have 6 minutes remaining. Okay, so we can still finish this one. Okay, so again, your divisor in here will be on, what specific number system you wanted this one to be converted to. So in here, it is asking us to convert this decimal into binary. So our divisor will be 2. So as you guys can see, everything is 2. Okay, so just copy this 137 divided by 2, which is equal to 18, remainder 1. And then 18 divided by 2 is 9, remainder 0. And then 9 divided by 2 is 4, remainder 1. And then 4 divided by 2 is 2, remainder 0. And then 2 divided by 2 is 1, remainder 0. And then in here, 1 divided by 2 is cannot be. So just put here 0. And then whatever is the value or the number on the integer quotient, which is 1, then copy that 1 as your final remainder. So again, our integer quotient is already 0, then that's the time that you have to stop dividing. And then you can now start reading the remainder from bottom to top. So 1, 0, 0, 1, 0, 1, which is now this one. All right. So from decimal to binary. Wherein again, of course, we only have two numbers, a 0 and a 1. So are we clear so far? Okay, very good, Miss Kyla, Mr. Van Luther, Miss Catherine, Mr. Perez, okay, Miss Johnny. All right. How about the others? Is there anyone who's confused right now? Please let me know so I can, give you guidance on which part you are confused. Okay, so I guess none. So I just really hope so that all of you were able to get this one. Anyway, so let's have one more example. So 2010 base 10, which is of course a decimal into octal. So in here, it is now asking us to convert this decimal into octal. So our divisor now is 8. So everything is the same process. It's just that your divisor now is 8. So in here, we need to use a calculator since this one is already uh, a large number. Okay, unless you're a genius and then you can solve that one, using your mind only, then no problem. Okay, you don't need to use your calculator. So 2010 divided by 8. So in here, I've got an exact result of 251.25. So we just put here the integer quotient, which is 251. And then in here, we have 0.25. So just get 0.25, multiply it to our divisor, which is 8. So 0.25 times 8 is 2. So that is our remainder. Okay. So that's how we've got these two right here. Okay, so get the decimal point as 1 and then multiply it to integer quotient, you will get 2. So just keep on doing that one. So 251 divided by 8, and then we will get 31.375. So 31 uh, will be placed in here, integer quotient, and then you can get the 0.375 times 8. That will serve as your remainder right here, which is 3. Okay, and then just keep on doing it. Okay, because your integer quotient is not yet 0. So 31 divided by 8 is 3.875. So 3 for the whole number. And then 0.875 times 8, which is equal to 7 for the remainder. So in here, 3 divided by 8 is cannot be. So just put here 0, and then whatever is the final value in integer quotient, and then that will serve as your final remainder. So since this one is already 0, then you can now read the remainder from bottom to top, which is 3732. Okay, PC. Okay, so wait, then there is a question. So sir, sa remainder po, paano po malalaman kung 1 or 0? Or paano po malalaman kung yung remainder 2, 3, 7, or 3 po? Okay, so going back here on how did we get the 2. So I want you, Miss Apple, to use your calculator. So 2010 divided by 8. Okay. So you will get exactly 251.25, right? So the 0.25 is the one that you're going to use to multiply to our integer quotient for you to be able to get the exact whole number remainder for this one. So 0.25 times 8 will give you 2. okay, which is now this one. Okay, so just keep on doing that one. So 251 divided by 8, you will get 31.375. So 31 for the whole number or integer quotient, and then 0.375 times 8, okay, is equal to 3. Okay, so just multiply the decimal point to our divisor for you to be able to get our remainder. So, another question. Sir, ask ko lang po ulit, paano po naging 2010, 251, 31 po ang na-divide sa 8? Ha? Paano po naging 2010? So, originally, we've started with 2010. Okay? And then, from here, we've divided this 1 by 8 since it is asking us to convert this 1 into octal. So, octal has a base of 8. So, 2010 divided by 8 will give us 251. And then